Hi, and welcome to section 6.1. We're talking about describing relationships and using scatter plots to do so. So today we're going to talk about scatter plots, setting up. We already did a little work in setting up scatter plots, but we're also going to talk about correlation. So do you notice a relationship? If so, what is it? And you take a look here and you see it's weight versus miles per gallon scatter plot. So we're talking about vehicles here. And if you take a look at this, you notice that there is a pattern that's going on here. The pattern is, well, in this situation, the heavier the car or the more weight that we have, the lower the miles per gallon. So what would the relationship be? This would be a negative relationship, whereas one goes up, the other one is going to go down. Likewise, if you work backwards, as your weight goes down, your miles per gallon goes up. So it's a two-way street there, where you can think about it as that. But the big picture, ultimately, they're going to be moving in opposite direction, so it's going to be a negative correlation there. So scatter plots, what are they? Like I said before, we did a little bit of work with these before earlier in the term, but once again, they show the relationship between two quantitative, so two numbers, variables measured on the same individuals. So one is going to be the x-axis, one is going to be the y-axis. So remember, the x-axis is down here, the y-axis is the one that goes up here. X-axis here, y-axis here. The data point shows the coordinate, so the location of it. So if we were to pick out one in particular here, let's just say we picked out this one, we would see that this individual had weighed about maybe a little under 180. We'll call it 179, and had a height of, let's see, I missed the mark there a little bit. Had a height of, 67 inches. So we can see that that is one particular individual that has those two quantitative variables that are about whatever that individual is. And in this case, it's weight and height. Also, we have size in carats here and price. So, what are we talking about? Diamonds or gold or whatever the situation is. As you can see, the size of it is the size of the carat increases, or the size of the diamond or whatever it is increases, the price also increases. So you take a look at that in the scatter plot, it displays the data. When examining, look for overall patterns or striking deviations so you can describe the overall pattern of a scatter plot form, direction, and strength. So we want to be sure to recognize outliers as well. So if we had this right here, this weight versus miles per gallon scatter plot as we saw before, and all of a sudden we looked and there was a data point that was up here. Now, notice that this data point falls pretty far outside of the data. This is actually going to have a pretty big effect on our correlation there, this one outlier is. So we can do some certain things with it, but we'll talk about that and recognize outliers as we work our way through here. So scatter plots that are positively associated, this is a very wordy definition that basically it says it slopes upwards from left to right. And negatively associated slopes downward to the right. So if you think back like a linear function with a positive slope, it's going to go up to the right. A linear function with a negative slope is going to go down to the left. So it's kind of the same idea here, but the definitions: above average values of one variable are accompanied by above average values for the other. Likewise for below average. So in this situation, and what that means is, let's just pick out a point here. Let's just say, for instance, if this was our average time spent studying here, this would be our average time student grades right there. So now what this means is, I'm going to change colors here, above average values in one variable. So I'm going to go above average in time studying are accompanied by above average values for the other. So if I spend extra time studying, if you look to where about that goes, you're going to see that you're moving in the same direction. So as this one goes up here, this is going to go up from your mean right there. Now it's saying likewise for below average. So if I was to take this and if I was to go below average here, this will map us to a spot that is below average here as well. So above average to above average, so above, we're going positive direction here, is going to map us to a positive here. And if you think about your say your rise over your run, your up and down, this is positive, this is positive, it's going to give you a positive slope. This right here is going to be minus, because we're going to take our mean and subtract something. This is going to be our mean and subtract something as well. So this would be a negative over a negative, which both a positive and a positive is going to give you a positive, and a negative over a negative is going to give you a positive as well. So kind of an over explanation there, but it's important to know what's going on with negative associations, and kind of the same story over here. We'll move a little bit quicker. So let's just say that this is our average and this is our average. If I were to go in the positive direction here, notice that that is going to map us to a spot that's going to be below average here, because we got to go down from there. So one is positive, the other is negative. You got a positive, a negative over a positive is going to give you a negative. Also, if I went below average in this direction, that's going to map me to something that is above average here. So it's going to map me to an above average. So this would be a positive, this would be a negative. So a positive over a negative would also be a negative. So that's just what those mean, the positive association and the negative association. Once again, like I said, a little bit of an over explanation, but it's important to know what goes into it and to see what is accompanied in a positive and a negative slope there. So correlation, this describes the direction and strength of the straight line relationship between two variables. We call it R. So R is our correlation, and we'll talk different things about correlation here as we work our way through. A positive R value indicates a positive association between the variables. So you can look at this and you can say that this is going to be a positive correlation, because look at your data. This is going to be a positive correlation. Look at your data. It has that positive slope. And these are all going to have negative because they're going down to the right. And then something like this will have no correlation, but we'll discuss the values and what they look like as we work our way through here. So negative R indicates a negative association. So positive gives you a positive slope, negative gives you a negative slope. Correlation always is going to fall between -1 and 1. So -1 and 1 are going to be your perfect correlations. Those are going to be the ones that fall perfectly in a line, a -1 and a 1. Remember, the negative value, the negative number says it's a negative association. The positive tells you it's a positive association. So if I was to make a little chart here displaying the strength of, say, a correlation, and the stronger, the higher the strength of the correlation, the closer to -1 or 1 I am getting. So it's okay to be, -1 and +1 are the same strength. They have the same magnitude. It's just the negative sign in front tells you that it's going to go down. So kind of like this line right here, anything that has a negative correlation, it's going to look like the data is going down to the right. And here, once again, your strength is going to top out here at 1, and it's going to look like a positive line. So this is a nice little diagram here with your R value. Notice at 0, you're not going to have any straight line relationship there. So it's very weak if your correlation is close to 0. Correlation does not change when we change the units of measurements. So if we were to do height and we originally had it in feet and pounds, we could change it to meters and kilograms, miles and in grams. We could change it to any of those height or weight, and the graph will look like it changes, but the correlation will not change. So the graph might appear to be a little bit different because you have different numbers. Feet are not meters, so they're going to look a little bit different. But the correlation or the strength of the relationship is going to stay the same. So we can change the units, but the correlation stays the same. The correlation ignores the distinction between the explanatory and response. Now, in some situations, there is an explanatory and there is a response that you're measuring, but if we flip-flop those two, the correlation is not going to change. So in some situations, you look and you say that, okay, this is causing this, or I'm going to say that this is the explanatory piece here, like studying in grades. The more you study, the higher your grades are going to be. Well, we would say that the studying, the amount of time studying is going to be the explanatory, and the grades is going to be the response variable in that situation. And we would say that that's there. But what we could do, we could reverse the variables, and the correlation is not going to change. The relationship is the same, regardless of what it is. It's just our need to have a explanatory and response is going to be a little bit different. So correlation measures only straight lines. So we're going to talk about straight line relationship here between the two variables. So if I had a situation where, you know, my data looks something like this, and you can see that there is a clearly a relationship between those two variables, the x variable and the y variable here. But if you take a straight line, it's going to be, you know, it's going to be hard to put a straight line in there that fits the data very well. So this would have a very low correlation for the correlation that we're talking about, but we're only talking about straight line relationships. So just because the correlation is low doesn't mean that there's no relationship at all going on there. The correlation is strongly affected by a few outlying observations. So where you have something like this is a strong positive correlation. If you had one point out here, that's going to have a significant effect, because this one right now, as is going to be very close to 1, a positive 1. If we put something out here, that's going to have a major effect on that and bring it closer to 0. So setting up a scatter plot, doing it by hand, I'll just use some of these data points right there, just quickly run through how to do it with you. I'm confident that you know how to do this, but you can do it here with, you know, by hand. You can set it up. You know, your height is your x and your shoe size is your y. So 61, 12. You're going to locate 61 and you're going to go up to 12. So 61, 12 is going to be somewhere up there. Oops. 6112 is going to be somewhere up there. 6511, so we're going to take that and we're going to go 65 and we're going to go up to 11 right there. 67, and I think you get the picture on how to do this. We're graphing 1 on the x and 1 on the y. 72 and 13, so 72 and 13, and then 70 and 14. So you can see plotting your points, you know, based on x and y, and you have some relationship there. So that's just how you do it. We're going to use an applet online that's going to do it for us. But in the event that you wanted to do it by hand, you locate the x, you locate your x down here, and you go to the corresponding y. But like I said, I'm confident that everybody knows how to do that at this point. The correlation, how do you find r? I'm not going to have you do this by hand, but if you wanted to do it by hand, notice that it's a product of the z-scores. So we need to know the mean and standard deviation of each of the sets, so the x and the y set. So if, you know, our x up here was height and our y was shoe size, we would need to know the mean and standard deviation of the height as well as the mean and standard deviation of the shoe size in order to calculate the correlation. So we take the product of the z-scores and we sum it up. So it's the sum of the product of the z-scores divided by the number of observations minus 1. So that's our calculation that's going to give us this correlation there. I'm not going to have you do that by hand. We're going to use our applet here, and I'll show you how to run through that with this practice problem here. So R is our correlation. That's what we're looking for. So this will be the last slide here. We've got our practice problem. We want to use this. I put a link for this in the classroom, so you have it. You can go in there when it asks you to put together and find correlation for that. So we're going to bypass this, and we're going to let the computer do the work for us. So let me pull up my. I already searched for it. So if you can search for a scatterplot generator. Otherwise, you can use this one that we found online here. To do this. So what you're going to do is you're going to go up to the box here and you're going to enter x comma y values, numbers only. So notice it says numbers only. So this is going to bring up that, and I'm going to use these pieces right here. So my femur and humerus. So scientists found the bones of an ancient Archaeopteryx. To check the bones belong to the same species, we're going to check the correlation. Okay, we're going to look at the scatter plot. We're going to check the correlation. So the femur and the humerus. So we're going to type in those, and it's going to be 38. Comma 41, okay, and then we're going to hit enter, and then we're going to go 56, comma 63, and then we're going to hit enter, and 59, comma 70, Notice how I'm doing all of these data points together, 5970 and then 6472. So 64, comma, 72. And then the last one, 74, comma, 84. 74, comma, 84. So when we look at this, we're going to see if this falls pretty close in a line, we can say that, okay, there's a strong correlation between these, or there at least looks like a relationship between the femur and humerus, so we can check to see if they belong to the same species. So we're going to submit data, and we notice we have a sample size here of 5. And if you look at that, that looks pretty close to a nice tight line for us here. So that scatter plot has been created for us. Now, if I could draw your attention down to the bottom here, this correlation coefficient link down here, what it's going to do, it's going to take our data and it's going to give us that correlation coefficient. And we can judge to see if this is a pretty strong correlation or not. So right here, the correlation coefficient that it gives us, so we plotted the points and we looked at it, our correlation coefficient is going to be 0.994. So R equals 0.994. Look at that, and that is very close to 1. That is very close to a perfect correlation. So let's zoom out. Let's look at this one more time. Let's look at this scatter plot. And actually, we can look at linear regression. We'll talk about that tomorrow. But linear regression draws a line in front of it for you, so you can take a look and you can see that those fall pretty darn close to perfectly in a line, as evidenced by our 0.99, where are we? Our 0.994 correlation. So that is relationships, that's correlations with scatter plots, and working to find what the correlation value is. We're gonna let the technology do